Okay, it is live now. YouTube पे.
Okay, we are live now, sir.
Okay, नमस्कार और एक बेहतरीन लंच के बाद आज के तीसरे चरण में हम पहुंच चुके हैं और तीसरे चरण में जो लंच के बाद का सेशन होता है वो आम तौर पे थोड़ा डिफ़िकल्ट माना जाता है क्योंकि फिजिकल सेशन होता तो मैं ज़रूर बताता श्रोताओं को कि श्रोतागण जो है आमतौर पे श्रोतागण में कन्वर्ट हो जाता है और ये भंडारी साहब की अब जिम्मेदारी बन गई है कि हमारे श्रोतागण को सोतागण न बनाए और मैं यकीन रखता हूं कि उनकी जो सोलर इक्लिप्स पर जो टॉक है वो डेफिनेटली ऑडियंस को बहुत पसंद आएगी। उससे पहले मैं चिंतामणि पाई को रिक्वेस्ट करूंगा कि वो इस सेशन को मॉडरेट करें और हमारे डॉक्टर सत्येंद्र भंडारी जी का लोगों से परिचय कराएं। चिंतामणि जी।
थैंक यू सर, गुड आफ्टरनून टू एवरीवन। ये मेरे लिए बहुत सौभाग्य की बात है कि मैं डॉक्टर सत्येंद्र भंडारी का इंट्रोडक्शन दे रहा हूँ आज के ऑडियंस को। और सोलार एक्लिप्स हमारे काफ़ी करीबी टॉपिक है क्योंकि एक्चुअली मोस्ट ऑफ द टीम मेंबर्स ऑफ स्पेस गीक्स दे हैव स्टार्टेड देयर रिसर्च करियर फ्रॉम सोलार एक्लिप्स। और हमारा जो पहला पब्लिकेशन था वो एन्युलर सोलार एक्लिप्स के ऊपर था जो हमने 2010 में रामेश्वरम से हमने ऑब्जर्व किया था एंड वी एक्चुअली मेजर्ड द स्पेस the charged particles, cosmic ray particle variation coming from space. तो वहाँ पे Department of Atomic Energy, they actually supported us to carry all the detectors and we went there as a team to perform few experiments. So we are very fortunate to have Dr. Satyendra Bhandari sir with us for today's event, National Science Day. And I'm sure all participants जो स्टूडेंट्स है, टीचर्स है, they all will enjoy this session. And as we know that solar eclipse, lunar eclipse, it's the game of shadows of celestial bodies. So in this topic, I am sure experts like Satyendra Bhandari sir will enlighten us about this celestial game of hide and seek. So with that, I'll officially introduce our today's session's speaker, Dr. Satyendra Bhandari. So Bhandari sir was born in July 13, 1947 at Jodhpur in Rajasthan. After graduation and post-graduation in physics from Jodhpur University on merit scholarship, he was selected as a PhD scholar to work under Professor U.R. Rao at the Physical Research Laboratory, Ahmedabad. As PhD scholar, he represented India as International Astronomical Union Young Astronomer and received Brightest Among Participants certificate from International Astronomical Union in 1973. He devised and demonstrated an innovative ground-based radio astronomical technique to study cometary plasma and discovered the phenomenon of cometary scintillation. After his PhD, he joined ISRO as a scientist at ISRO Satellite Center at Bangalore in 1979. As a mission planning specialist, he was instrumental in the successful activation of the TV camera on board India's first remote sensing satellite Bhaskara 1 and obtaining the first ever historic space-based images of the Earth from it. Subsequently, over 30 years as a scientist at the Space Application Center, Ahmedabad, he developed innovative geosciences applications using data and images from Indian, US, and European remote sensing satellites in near Earth and geostationary orbits, as well as from Soyuz and Space Shuttle manned space missions. So among near Earth satellites include Bhaskara, IRS, NOAA, ERS, TOPEX, OceanSat, QuickSat, JSON, and among geostationary it includes GOES, INSAT, and Meteostat. He was PI for ESA ERS SAR project during 1992 to 1995 to study internal waves in the ocean During 1998 to 1999, Dr. Bhandari was selected to serve as Associate Project Director of Index Project, which was US NSF funded multinational, multi-institutional, multi-million dollar project. Simultaneously, he was also visiting research physicist at the University of California, San Diego, USA. As a part of IndoX, he also served as resident research scientist at world's most sophisticated Kashihodu, Kashidu Climate Observatory in Maldives on tiny island in the Indian Ocean. In 2003, Dr. Bhandari led the 3-week long, highly successful Indian Antarctic eclipse expedition to undertake highly challenging and adventurous scientific observations during the rare and unique total solar eclipse near Maitri, Antarctica on November 23, 2003. He varied His varied experience in solar eclipse observations has earned him a place in Global Eclipse Veterans List. He made significant internationally recognized scientific contributions towards utilization of India's OceanSat 1 for Antarctic sea ice studies and publication of colorful SAC-NCOR Atlas of Antarctic Sea Ice. He has wide variety of publications in international journals in the areas of radio and X-ray astronomy, astrophysics, comets, eclipses, and remote sensing of Earth's atmosphere, oceans, and Antarctic region from ground, from rockets, and from space. He has keen interest in popularization of science and is a life member of Indian Remote Sensing uh, ISRS, Indian Meteorological Society IMS, and the Indian Society of Geomatics ISG. He served as the chief editor of Megha, the IMSA newsletter, and Climate for You newsletter brought out by ICSSIR. He has contributed to outreach activities through invited talks on WM Day, World Environment Day, articles, newsletters, and newspapers, and a few radio TV appearances. With enthusiasm and interest, he has participated in GK quiz, slogan writing contest at SAC, and has won prizes. He has designed covers of books and proceedings and logos, and Christian ISRS newsletter signatures. He is also an elected life fellow of IETE. His scientific research has won him international research fellowships and grants, and his sense of scientific adventures has taken him to many countries and continents on challenging ship cruises and expedition to both polar regions, Antarctica, and the Arctic. Post superannuation from ISRO, he has actively contributed as visiting professor at NCOR, BISAC Gandhinagar, and ICCS SIR Ahmedabad. He continues his keen interest in the scientific research and outreach and is open to collaboration. So, thank you very much, sir, for joining us today on National Science Day, which is of prime importance to this country. And I'm sure all the students, youngsters, and teachers, science enthusiasts who are watching this program online, I'm sure they will be highly encouraged and inspired by your talk today. Thank you very much, sir. So I request Dr. Satyendra Bhandari to start with his talk.
Thank you, Dr. Chintamani. Very nice of you to have given a detailed introduction of my background in science. But as you notice, I am a person who is interested in variety, not sticking to one particular thing. And then it so happened during my research career that I had to keep on changing fields, my research fields. So, right from astronomy, looking up into the sky, and then looking down on the earth from space and all that. So it has given me very exciting, adventurous experiences. And this today's talk is more or less, it is basically trying to convey the scientific adventure that is involved in making observations during eclipse. As many of you know, and then some introductory slides, you can see how exciting the thing is. So let me begin by sharing the presentation. So I just hit the button share screen. Where is that?
Yes, sir. You have to just press this share screen button.
You'll have to,
Share your
yeah.
entire screen.
Let us see I hope it will work.
Yeah, it is coming.
Okay, so I'll make it full screen.
Yes, yes. Good. Okay.
Okay, then can I switch off my video so that
Yes,
I
sir.
can save some data?
Yes, sir.
Okay, so this is full screen, and then I switch off my stop video. Okay,
So you can keep
so
your
let
video
me
on.
begin by
keep your
saying,
video, sir.
In case of there is a problem, we can inform you.
you want my video?
Yeah, video
Yeah, because
also.
then YouTube people can see you as well.
Okay,
Sir, you.
I hope I will not end up with the data problem. Let us see. Okay,
No problem, sir. We have switched off our video. Your video is required.
doesn't matter. It's a two-way exchange of data. So
Yes.
anyway, fine. So this is the topic of my presentation today. This is solar eclipses, observations from space and from Earth. So now, since morning we have been talking about National Science Day today, and in my talk I wish to bring out some unique and exciting aspects of learning about nature through phenomena of total solar eclipse. The basic idea would be to convey to the students of science the excitement and adventure of undertaking scientific experiments. The stage is already set by the earlier speaker, Dr. Ranade. Is it okay? Hello.
Sorry for interruption, sir. You can go ahead. Sorry, it was.
Okay. So in the morning, earlier two talks have given us a good starting point. And as you can see, science is all about doing experiments in the laboratory, like what Dr. Sir C.V. did and earned the Nobel Prize, or about thinking about ideas in theoretical, like this formation of birth and death of stars and formation of neutron stars, black holes, and all that Professor Kale talked about. So it's all a fascinating way, but only all this uh, even theoretical have to be somehow validated by experiments. So there are many different ways of doing science. So in my today's talk, total solar eclipse is just one of the ways of looking at the fascinating astronomical phenomena, and then try to make use of this opportunity provided by the cosmic laboratory, provided by nature, to try and understand what we can learn about our world or the universe around us, or the sun, moon, and the planet. So my talk I will try to cover in three parts. One is the phenomena of total solar eclipses, how unique is this phenomena, and what are its attributes. And then I try to dive basics about which most of you know, basic things about how its eclipse takes place, what are the various parameters that are associated with it. And then in the second half of my talk, I'll try to describe what experiment or the campaign I launched to look at the total solar eclipse, look at the Earth during the total solar eclipse from space. Normally, the most popular aspect is to look at the sun during the eclipse and enjoy the phenomena. Of course, that is certainly very much true, but I try to think of a new or innovative type of idea to look at it from space and then try to see what are the things we can learn from it. And this was during the total solar eclipse that took place over India during October 24, 1995. That was the Diwali day in 1995. So you will be surprised why I am talking about such a event or such observations even 25 years later. But I will try to convey the excitement and the details that are involved in planning such an experiment, how exciting and adventurous it was. And then, of course, I have been involved in many other eclipse events in different places on the earth. So I'll begin with my talk about, first of all, look at the total solar eclipse in the context of what we see in the sky, and then try to learn that whether total solar eclipses are run-of-the-mill events, or whether they are very special type of events. So just a second. Okay, it's now the pictures are hiding my slides, so how to do it? Anyway, so it is always wonderful and fascinating to look at the sky, particularly the night sky, and amazing display of stars, nebulae, the Milky Way, and the other galaxies, and so on. So for a long time, I have used this tagline in my email: "Look up, and the sky will never let you down." This means it is always wonderful to look at the sky, and you will be always fascinated by what you see. So it is always what you call encouraging and exciting to look up, and you will never be let down. That means you will always learn something or enjoy something. But soon, you see, the unchanging monotony takes over in the sense that you have the same Milky Way, you have the same set of stars, and some little movements of planets here and there, but nothing so remarkably changing. So one cannot enjoy and enjoy the same things repeatedly occurring again and again and again, over and over. So what makes the sky and the universe at large exciting is the change actually that takes place or is brought about by numerous kinds of astronomical events. So first let us look at the uh, exciting events that we normally hear about when astronomic research is talked about. So first of all, let us look at the highly energetic cataclysmic events like what Professor Kale talked in the morning: birth and death of stars, formation of supernovae, pulsars, neutron stars, black holes, and collisions and merger of black holes, and etc. These are highly interesting and exciting astronomical events, and their study has allowed us to learn about the mysteries of the universe. But again, these are in the realm of professional astronomers with their specialized equipment. Normal human beings on the surface of the earth, or most of us, cannot easily grasp what type of experiments are being done, how these objects or the events are observed, and all that. Then sorry, next comes the birth and so these are some examples of the birth and death of stars. This is the Orion Nebula and the other nebula where a lot of star formation is going on. And then this is the aftermath of a death of a star. This is called Crab Nebula, or the supernovae that exploded long time back. And these are some imaginary or artistic ways of presenting how the black holes go around each other, or they merge, or they collide, and all that. The next set of events, astronomical events, relate to movements of planets and comets, asteroids, etc. This is mostly occurring within the solar system, within our solar system. These are nighttime events. These are amenable for both the professional as well as the amateur astronomers alike. And their studies have given us much understanding of the origin and evolution of our solar system. The next set of events, there is another category of interesting astronomical phenomena or events that do not involve any energetic processes like the birth and death of stars or other things like that. Even the comets, when they enter the solar system, their material evaporates and all that. But here is another category of interesting astronomical events or phenomena that do not involve any energetic process. These are called or come under are defined under the category of occultations, eclipses, and transits. These three terms are basically describing the same family of processes. These are astronomical events. They have their own importance in terms of discovering planetary orbits, size and structure and atmosphere of planets, etc. And many times the transit of Venus and Mercury across the face of the sun, you can study the planetary sizes and their atmospheres and all that. And as you know, many of you know, discovery of Neptune's rings were discovered during stellar occultation. And this these occultations and transits have been used to discover a large number of exoplanets, that is planets that are found moving around stars outside the solar system and within our galaxy. And this is a very exciting topic to follow these days. A number of discoveries and number of satellites are being launched to discover these exoplanets and try to understand whether life exists elsewhere in the universe. The occurrence of lunar and solar eclipses that the topic today, they fall into this category. These are just some examples of this is transit of Venus across the disk of the sun. This is the transit of Mercury across the disk of the sun. This is the stellar satellite of Jupiter Europa is occulting a star. And these are of course the lunar occultation and the solar occultation. I will describe more details about this as I go along. So out of these, the lunar and solar occultation, the size and distances of the bodies involved. That means in producing the event, that is the lunar and solar eclipse, the sun, moon, and the earth, their distances and sizes are such that lunar occultation does occur, but it is not so very exciting even to watch in the sky. What happens is that Earth's shadow falls on the moon, and there are some changes in color due to the light of the sun passing through the Earth's atmosphere and creating the shadow. Whereas the solar eclipses, due to fortuitous coincidence of apparent sizes of the sun and moon as seen from the Earth, this produces the most exciting and awesome event. And most uniquely, it occurs during daytime. That is the most beautiful part of it. The, the event, even though it is called a celestial event or astronomical event, is one of those rare events which take place during daytime. So uniqueness of the solar eclipse phenomena does not end there. There are many more other attributes which make it more unique. The solar eclipse event does not require any special effort to see or to witness. The eclipse by itself, because it changes your environment during daytime, it catches the attention of all inhabitants living in its path. So it's a very wonderful type of event. One does not have to look for or wait for it. It is automatically become apparent to the people who are lying in its path. Then, of course, one can take interest and try to study the events and learn more about it. So, to summarize, the solar eclipse and particularly a total solar eclipse is the most unique, highly mesmerizing, and awesome astronomical event taking place during daytime sky. The occurrence of a total solar eclipse, a wonderful experiment conducted by Cosmic Laboratory, is also of great scientific importance, as we will see how eclipse events have been utilized for understanding various aspects of the universe and the solar system. Now, there is another uniqueness that is associated with it in terms of it's not a scientific thing, but certainly out of what people have been studying astronomy. For example, over hundreds of years, people have studied planetary orbits and studied the universe, and finally it ended up dislodging the Earth as the center of the universe, which was earlier thought the Earth was at the center of the universe. And then eventually it dislodged the Earth as the center of the solar system also. So we know now that center of the solar system is Sun. Earth and planets are moving around it. That's the heliocentric solar system. But one thing still stands absolutely unique that has not yet been displayed by other things to best of my knowledge as far as the Earth is concerned, and that is the occurrence of total solar eclipses. Nowhere else such a combination of size and distance to its star and its satellite exists to produce a total solar eclipse on a planet like Earth. So this is still unchallenged in terms of its uniqueness. So as we have seen, total solar eclipses have many of the uniquenesses associated with it. So in my talk, it's all about bringing the uniqueness of the total solar eclipse event and describe how, when, why, where, and what opportunity these events present for an inquisitive scientific investigator, and to share my excitement and adventure of being in the moon shadow on many occasions. So this is just to tell you about my eclipses, in the sense that over last 40 years, I've been witness to a total of 6 solar eclipses, one annular solar eclipse, and as it was presented in the before the talk, many of the images are shown which relate to these eclipses. Of course, some are occurring over India. That is February 6, 1980 eclipse over southern peninsular India, and I watched it from Bangalore. But it was just out of curiosity. I just made little observations. But in October 24, 1995 eclipse over northern India, I did a very elaborate space-based experiment, and that is what I will be describing. But this was all sitting in Ahmedabad in my room, so there's no big experiment in the sense of taking telescopes or looking at something. But I utilized the existing capability that was around me. Then August 11, 1999 was a total solar eclipse whose end was near, it was ending near Bhuj in Saurashtra, and I went there to enjoy the eclipse. Then there was a total solar eclipse which was most unique and most rare eclipse over the continent of Antarctica. And perhaps it was taking place for the very first time after Antarctica was discovered. So the November 23, 2003 eclipse was absolutely unique eclipse, and he led a total solar eclipse expedition to make observations during this eclipse from near Maitri, because the path of totality of this total solar eclipse was passing close to our Indian Antarctic station Maitri. Then, similarly, during August 1, 2008, another polar eclipse was taking place over northern Arctic region, and we made observations from near our Indian Arctic station Himadri. Then there was the longest of the century total solar eclipse, July 22, 2009 over northern India, but it was fully during the cloudy monsoon season, and most of the places the eclipse observations were affected by that. And then the last eclipse which I observed from southern India is January 15, 2010, annular solar eclipse from an island in Gulf of Mannar. And we try to make some observations related to how the sea creatures behave. But it was not very easy to make out what is really happening. So I'll continue my presentation on what is the total solar eclipse. So for the observer on the Earth, a total solar eclipse is undoubtedly the most awesome and spectacular solar event. As you can see, when eclipse takes place, you can see a panoramic view of the sun blotted out, and you can see the solar corona. So due to the fortuitous coincidence between the angular sizes of the sun and the moon in the sky, the moon's disk nearly exactly covers the sun's disk during the total solar eclipse. And this produces a wonderful and marvelous spectacle in the sky, in the process revealing the otherwise invisible solar corona. Now during the TSC, the sun and the moon perfectly align in the sky for the observer on the Earth. But such alignments are quite rare, last only a few minutes, and occur only few times a year. So one has to wait for such events to occur in nature. This is how the that's how these solar eclipses take place. In this slide, you can see this is the apparent motion of the sun as seen from the Earth. Actually, the sun is at the center and the Earth is moving around. But if you look from the Earth, this is the ecliptic path, that is path over which the sun moves. And then the moon moves around the Earth in an orbit which is tilted roughly 5 degrees with respect to the ecliptic. So moon and sun comes together or in the same direction in the sky only when the moon passes through these nodes where the two orbital planes intersect. So only during such time there is a possibility of formation of solar eclipses. At the same time, whenever, excuse me. Okay. So not always when the sun and moon, when the moon comes on around these nodes, you can not always have the solar eclipses taking place because the actual size and the position of the moon and the sun have to be really coinciding. Then only the solar eclipse can take place. So there are many gaps in the thing. There are many cycles when total solar eclipses take place and all that. So when total solar eclipse takes place, the sun is slowly blotted out of the moon, and during the totality, when the sun is fully blocked, you have a view of the sun which is showing the corona, and the entire solar disk is blocked out. So eclipses occur when the near new moon time, when both sun and moon are sufficiently near to the nodes, when the moon's orbit around the earth crosses the plane of the earth's orbit around the sun. So when this particular alignment occurs, we have the shadow of the moon is the sun, the shadow of the moon is falling on the surface of the earth, and this is the umbral shadow. That means where no sunlight is able to reach, and then there is a wider penumbral shadow where little bit of sunlight is able to reach. However, this path of totality, that is where the sun is totally blocked out, is not very wide. You can see because of the size of the moon and the distance of the moon, this path is very narrow. So one has to be within this path to be able to observe total solar eclipse. Now the sun and the moon, as I said, they have same angular size and their rare alignment in the sky is producing the total solar eclipse. Another very interesting thing is moon is a dark, non-luminous object. In the sense that if it was a very luminous object like a star or any other thing, then it will not be able to produce a discrete cover on the surface of on the disk of the sun. So this is without any atmosphere. So it's ideal to block the sun very discreetly and we can enjoy the solar eclipse beautifully. Now, total solar eclipse occurs only for the earthlings to observe. That means for the inhabitants of the earth to observe, appreciate and enjoy, and perhaps proving the existence of intelligent life only on the earth till we discover either new coincidences of this type or we discover life elsewhere to see whether such a thing is possible in other places. Now, as I said, this occurrence of eclipses or the total solar eclipses, they serve as a unique natural laboratory for scientific investigation. Now, I will try to describe some unique attributes of this type of events, that is total solar eclipses. So first of all, these eclipses are highly predictable. The occurrence of these eclipses are very highly predictable much in advance. That means even hundreds or thousands of years in advance. One can know where the eclipse will take place, and then there are no uncertainties regarding how it occurs, why it occurs, when would it occur, where would it occur, and where it will be visible. So to whom it will be visible, which part of the earth will be visible. Everything is very well known in advance. And what will be the celestial circumstances? This means in which part of the sky it will occur, what will be the elevation of the sun and moon during the time of the eclipse, and other type of things. So it's a very unique attributes about the system. For example, many astronomical events which I described earlier, we don't know in advance when they will occur, except for probably some transits and occultation. But most of the other energetic events that take place, we are taken by surprise. Only when we suddenly observe something by chance, then people start following and trying to determine their properties and their recurrence periods and all that. So this is a very unique attribute of total solar eclipse occurrence. Now, as I said, time and place of occurrence of eclipses in general, and particularly total solar eclipses are possible to predict precisely much in advance, in decades and centuries in advance. This allows sufficient time to plan innovative scientific experiments and observations. However, The moon's umbral shadow on the Earth, as I said, is very small and it moves at a supersonic speed because of the motion of moon in its orbit and the motion of Earth or the rotation of the Earth. These total eclipse conditions occur over a very narrow strip of Earth and last only for a duration of few minutes at most. That means about at the most about 7.5 minutes at any given place. So this requires tremendous efforts in planning, preparation, and flawless execution of the experimental plan, including travel to the place if it is not occurring over your place of stay. In terms of instrument preparation, in terms of calibration, in terms of redundancy, everything has to work perfectly. Then only the experiment can succeed. But more importantly, secondly, there is no possibility of a retake or a second take. In most of the laboratory experiments or in other situations, we may try to correct our mistakes and do the experiment again. But in this case, there is no possibility of a retake or a second take. A total solar eclipse is a short-lived one-time event, not likely to repeat at the same place for a long period, maybe decades and centuries. And the conditions of occurrence of such an event are totally beyond the control of any of the mightiest observer on Earth. This means it will take place where it is destined to take place. So you have no control. Only you have to be prepared fully to make use of this for any scientific observations that you want to make or just to enjoy the panorama in the sky. The only difficulty once the eclipse takes place, the only difficulty is that unpredictable weather around in the atmosphere of the Earth. For example, atmosphere of the cloud may sometimes totally spoil the sky. So continuing on to describe what is the scientific importance of total solar eclipses. In order to make use of these cosmic experiments done by the occurring in nature, scientific groups have traveled across the globe for the last few hundred years to remotest part of the location, remotest of locations, and have innovatively exploited the occurrence of total solar eclipses to make exciting observations and fundamental discoveries. As was talked in the morning, there are many discoveries that were achieved during the total solar eclipse events. First of all, the discovery of solar corona and the solar atmosphere and the structure within the solar corona which were not easily visible could be seen during the total solar eclipse events. Now, discovery of the element helium. When spectroscopy observations of the sun were taken from Guntur, India, during the eclipse on August 18, 1968, a new line in the spectra was observed, and finally it was observed that it was an element helium which was not earlier known on Earth. So the spectrum observations during a total solar eclipse led to the discovery of the element helium, and that is why it has been named helium. Helium is for Helios. Now, as Professor Kale mentioned in the morning, confirmation of gravitational bending of light, as predicted by Einstein in 1905, was also confirmed during an eclipse on May 29, 1919, almost 100 years back. Similarly, when the eclipse takes place, you are able to see the surroundings of the sun or the solar atmosphere to a larger distance very clearly, and many times not normally observed comets have been seen approaching the sun or falling into the sun. So there is a new class of comets they call uh, comets falling into the solar system, this disk of the sun, atmosphere of the sun. Therefore, the opportunity of such unique and rare experiments conducted by nature should never be left unexploited and unexplored to unravel phenomena and processes relating to sun, moon, and the earth. So this just described the occurrence of eclipses across the globe, and I tried to to look at the Indian region where we have been talking about these eclipses. You can see during the period 20-year period during 1981 to 2000, there have been these blue lines or blue paths are eclipse paths where total solar eclipse occurs. The red paths are related to annular solar eclipses. So you can see during 1981 to 2000, two solar eclipses took place over India. First was in October 24, 1995, where I did this experiment which I am going to describe. And second was the August 11, 2008 experiment, which took place over Bhuj. Now there have been many eclipses during the period 2000 to 2020. The first eclipse which took place over India is July 22, 2009. The longest eclipse of the century, and its path is like this. So it started from Western India and traveled across many parts of Northern India. Then there were two annular eclipses, both of which are passing over the Gulf of Mannar region on January 15, 2010, which I also observed. And then another was December 2019, and recently on June 1, 2020. During this period, there were other eclipses that were taking place over parts of the globe which were not geographically called in, cannot geographically be called India, but certainly they occurred at the Indian polar stations. One November 23, 2003 eclipse took place near the path of totality path very close to the Indian Antarctic station MAC3. And in 2008, August 1, there was another total solar eclipse over the northern polar region, and the path of totality passed very close to the Indian Antarctic station Kumadri in Svalbard, Norway. So these are the places I could go and conduct some experiments. I will not be talking about this Antarctic observations and the Antarctic expedition that we took, but I will be describing more details about the October 24, 1995 total solar eclipse, where I could do some experiments from space. Now the next 20 years, you have only one total solar eclipse passing over the northern end of our country, and there is another annular solar eclipse passing again over the Gulf of Mannar region. This is a very interesting observation. I noted that this region of Gulf of Mannar, where we are recently news about Ram Setu and all that, this region is frequently being visited by annular solar eclipses, and sometimes crisscrossing, in the sense sometimes it will be moving in this fashion and sometimes the path will be at a very different angle. So there are many series of pairs of such annular eclipses taking place. This is just an interesting observation. However, from now on, that is from 2020-21 on, there are hardly any eclipses that are going to pass over the Indian region. And for next almost over a century, there are no total solar eclipses taking place over the geographical boundaries of India. The next total solar eclipse that will pass over India is 2014, then 2024, 2060, 2114, 2100, that is 22nd century, 2168, and so on. Of course, we all know about their path of totality and the circumstances of the eclipse, but they are far, far in the future. So, if for those who are interested in solar eclipse studies, they will have to go to different places across the globe to make use of such events occurring elsewhere. So there is a very great interest in eclipse tourism and the travel opportunity that are involved, and then you come to know different places when you go there to observe the eclipse and all. So there are many such aspects associated with. There are hundreds of aspects associated with total solar eclipses, right from superstitions to science. I'm not going to talk about this, maybe some other time. So let me come to the main topic of what really happens during a total solar eclipse. Now with the moon and the sun aligned perfectly in the sky for a short duration to produce an awesome spectacle, nothing whatsoever changes in the character of the sun and the moon. They simply move in their unperturbed normal orbits. This is very significant because normally people think that the sun and the moon and everything changes different radiations take place, it is harmful and all that. But it is very clear that during the time of occultation, these two bodies, the sun and the moon, only align themselves in the sky. Both are very separated by millions of kilometers, and there is no connection between two except for the angular alignment. So, in their physical behavior or in their activity, for example, all the solar activity, the sunlight, everything is going on as usual. The real effect and perturbations, however, occur on the third body that is involved, that is from where we observe the Earth and on which the lunar umbra and penumbra fall. These perturbations, real effects and perturbations, they take place on the Earth and in its environment. These are constantly sustained by the energy from the sun. For example, when the solar eclipse or total solar eclipse takes place, for a period of few minutes over a given region, suddenly this entire solar input is cut off, and then within minutes it is revived again. So that provides a sudden jerk to the Earth's atmosphere and its environment, and then it tries to sort of react to that. So sudden removal and restoration of solar radiation input jolts the Earth's atmosphere in a very unusual way. And in the process of trying to adjust itself, a number of interesting effects and phenomena are produced. The unusual behavioral responses of these stimuli, that is the jolt or the shock that Earth receives, are observed in different spheres of the Earth. So, okay, this only shows that how the penumbral and umbral shadow is falling on the surface of the Earth, and this is a cloudy scene. So, on cloud tops, you can see the shadow. This is another taken from a space station. So I'll just describe various regions where these effects are observed. So first of all, when we look during a total solar eclipse, when we look at the sky, you see the total solar eclipse progressing from partial to total to partial, and then the entire atmosphere of the Earth, or this, because we are here in the standing in the shadow, the entire horizon is lit in a very eerie, different kind of colors and all that. And then the sky, of course, is very unusually different. Right in the daytime, you feel night-like conditions, and during the totality, the corona comes up so beautifully, and we can enjoy and study those regions. So this is the realm of the sky, that means in the astronomical side of the total solar eclipse. However, all the different layers of the Earth's atmosphere, right from the ionosphere to stratosphere to lower atmosphere and ground, they are affected in different ways. Because first of all, the solar energy is cut off, so obviously the ionization stops for a while, and then recombination starts in the ionosphere. Similarly, the stratospheric ozone production is stopped and then again revised. So then the shadow that is falling, the lunar shadow that is falling on the surface of the Earth, excuse me, it is moving at such a supersonic speed. So it produces its own effects in the ionosphere and the Earth's atmosphere. Then, of course, the ground cools down due to absence of the solar radiation and then tries to recover. At the same time, the entire biosphere, that is the plant and the animal world, also sees sudden changes because they are not able to adjust to the sudden night-like conditions appearing and disappearing. So they also have their behavioral changes. Describe the sequence of events that take place in the sky and in the Earth during the total solar eclipse. As you see, an hour or so before, or sometime before, a small portion of the sun is cut off by the moon, and then slowly, a crescent appears and the sun, and finally, the entire sun's disk is blotted out by the sun, and the solar eclipse or the corona is visible, and then a reverse sequence of events take place. So when there is a very little part of the solar disk is visible, It is it's part science through the moon's valleys and mountains and valleys, and they produce the effect called the diamond ring and the Baily's beads. And this is a very familiar kind of thing which I think most of the people are aware what takes place in the sky. Then the entire, even before the totality takes place, the reduction in the solar radiation start producing environmental effects much before the totality takes place. And they continue depending upon the response of the Earth's atmosphere even after the totality ends. Again, there is a very interesting phenomenon that takes place during just before the sun is blotted out fully, that means second and third contact, the phenomena called the solar twinkling effect takes place. Because during that time, for example, when you see the beads and the diamond ring, the sun starts behaving like a very pointed star, very narrow, compact star-like thing, and that eliminates the Earth's atmosphere, and the turbulence in the Earth's atmosphere produces certain kind of effects which are like uh, seen when twinkling of stars takes place. In a similar way, the solar twinkling effect is seen, and it produces bands of light and dark bands shadows, which are called shadow bands. So they can be observed to study the properties of the atmospheric turbulence. Now, this I will be talking about a particular eclipse that took place on the Diwali day in 1995, October 24, 1995. Oh, I am already running out of time. Anyway, this shows the path of totality, and you can see the umbral shadow size is such a small point on the sky, but this itself produces a variety of effects, and then one can try to set up an experiment to study what type of events are seen. Now, this is the track of totality of that eclipse, and you can see it passes from European regions to across the northern India and through Indonesia and finally over the oceanic regions. This particular this TAC event was highly attractive for space-based observations as well as watching the spectacle in the sky. In terms of its occurrence during the largely cloud-free season, Diwali is a cloud-free season between two monsoons, and is path of totality crossing the highly populated regions of North India, and it provided opportunity to millions of people to have unforgettable experience. Now, this only shows what are the major cities it was passing close by or over: Agra, Kanpur, Allahabad, Varanasi, Patna, Ranchi, and Diamond Harbour, Calcutta. A number of experiments were planned by many different teams trying to study the ionosphere, the Earth's atmosphere, and the like. Now, what I want to bring out this is that during that time we had a set of Indian geostationary weather observing satellites called INSAT, and they were located at 36,000 kilometers. So I devised a plan to monitor the Earth by using these imaging sensors in a very special, innovative manner. Normally the images that are created by this type of sensor is as a coverage of this type of very large coverage over the Indian region. That means right from western parts of West Asia to Australia, the entire thing is covered in one image, and you can have images every half an hour. However, during half an hour, the entire eclipse will move from one end to the other, and you will be able to have only one image. So what was tried was to use this facility on board that you can image a very smaller portion but more frequently. That's called the sector scan facility on this kind of imagers. And then there were three imagers available in the geostationary orbit over India. So one can do time staggering and then try to obtain more frequent images. So the idea was to exploit the unprecedented simultaneous presence of three geostationary INSAT VHR imaging satellites in space above Indian region, and then generate high spatial resolution and temporal resolution panoramic synoptic scale images of the Earth in visible and thermal IR band. These sensors make images in two bands covering the entire TAC proceedings. Till that time, no such experiment has been done. Only a single image during the entire total solar eclipse has been generated. So we use the sector scan facility that provides images every 8 minutes, and then we used 3 insets in time stagger mode. And it was a very complicated experiment because all the 3 insets have to be commanded for VHRR operation, and all the 3 insets, the data have to be downloaded at different places. One of the places was SAC Ahmedabad, other in IMD Delhi, and then third is in Master Control Facility Hassan. And then we tried to attempt and successfully did real-time analysis at SAC Ahmedabad. So simultaneous digital recording of the incoming solar radiation was also attempted from ground. So, and as for any scientific experiment to be successful, we must have control day observations also. So we did the entire exercise on one day earlier and then on the eclipse day. So this shows the location of the 3 insets that are on the equatorial region of the Earth. And then you can see each inset coverage is able to cover the entire track of the eclipse. So even if we have one sector located here, and then we stagger in time in different satellites, then every 8 minutes we can get the image. So this shows the sector scan. The size of the north-south size and east-west sector size is sufficiently large enough to cover the entire track of the eclipse. So we could get images every 4 minutes from different 3 of the satellites. A single sector was able to cover the entire track of the eclipse, so we didn't have to use the facility of moving the sector as the time goes by. So we did an entire simulation exercise beforehand to see what we expect from the inset images. And this is the entire digital simulation that was ready beforehand to see where the shadow will be, what type of coverage will be, and where we will be able to capture the images. This image shows at the end of the inset coverage zone how the shadow has moved, and you can see the shadow. This image is created in a Vibgyor color. So the red colors are the dark regions, and violet and all the colors are basically the clouds, which are very bright in the visible band. I'll try to go fast because I think time is running. Now, in terms of the results, you can see these are the images over the Indian region, part of the images that are expected from this. You can see the lunar shadow appearing in different places as time goes by, every 8 minutes, every 15 minutes. So you can see this dark region appearing on the northern region where the moon shadow has moved slowly from west to east. And these are the regions which are dark because sunrise has not yet taken place in these regions as the earth revolves around it. Now, similarly, this is the visible channel. Similarly, in the infrared channel, which senses the thermal temperature, surface temperature, you can see these regions which are becoming darker and darker in the sense that becoming cooler due to the arrival of the moon shadow. Further, the images will show that. So this is the region of cooling produced due to the umbral shadow. Now this is control day and the TSC day. The difference you can see clearly in this visible image. You can see this is India and these are all clouds and all that. This is Bay of Bengal. In the morning hours around 9 o'clock, you can see these are the colors, and when the shadow is present on the next day, the entire thing becomes very dark. So you can clearly portray the entire path of the eclipse and in both these frequency bands. Right from 222 to 339 UT, that means more than an hour. The number of images every 4 minutes were taken from 3 sets and in 2 bands. You can imagine the number of the images that were collected. So this is just a thermal IR band image at 222 and 238. You can see at 220 there is no cooling has taken place in the western part of India because shadow is still to enter to this. And then after some time when the shadow comes, you can see the entire area cools. So one can try to study how the thermal profile of these all places within the image. One can select any particular place and then try to see how the warming, cooling and recovery has taken. These are the thermal IR images at 3 different times. You can see the cooling is progressing from west to east. and over now it has reached the eastern region of the country. So these are some of the profiles that were derived using the thermal IR data. And you can see Western India, then how after the eclipse, the cooling, initial cooling and then recovery takes place. And the rate of cooling and the time at which the rate cooling takes place depends upon the type of soil or the type of surface conditions existing. For example, deserts, a very sharp cooling and recovery, whereas in places like Bombay, where the sea is nearby, the recovery is very, very slow and things like that. So one can try to study these properties of different types of surface. So the outcome was, it was first ever and as yet not repeated anywhere, space-based comprehensive high space-time resolution panoramic 3D visualization of the TSE event in real time, near real time. Quantitative digital data of the surface brightness and thermal changes for the entire region, Indian region with high space-time resolution was collected. Analysis of thermal cooling and recovery profiles for different surfaces was calculated. Now, we also did make measurements of the solar radiation reaching the surface of the Earth. And we had a Lycor radiometer which we put on the terrace and then collected the solar radiation every 10 minutes with a 2 nanometer resolution. The entire solar spectra was recorded on TSC day and control day. And as expected, one can see on a non-eclipse day, as the sun rises and comes above, the solar radiation increasing. But on the eclipse day, there is a dip in the solar radiation. And if we take the ratio, if the ratio is 0.17, that means 83% of the solar disk was covered as seen from Ahmedabad. So this experiment was also done from ground. So to conclude, we utilized the tremendous Earth imaging capability that existed in the form of free operational inside VHRR. No other country had that kind of luxury at that time or even probably later. An innovative plan was conceptualized and successfully executed to comprehensively monitor the effects of passage of moon shadow on the Earth's surface with high space-time resolution. Such an amazing visualization, which was useful in terms of scientific value, has also great educational value in the sense that people, when they see such kind of sequence of images, they can realize how the eclipse is taking place, rather than just having a geometrical drawing in the textbook, which only says that it's not to scale and all that. So this was a great experience to be under the moon shadow. And when those people who have been to the events like total solar eclipse events, there's a entirely fascinating and awe-inspiring events and a memorable lifetime experience. And in terms of one quotation that Bankim Chandra Chattopadhyay, oh, what a sight, unforgettable for many lives to come. So eclipses are certainly, total solar eclipse are certainly wonderful events. And this is just a composite of how the total sequence of this eclipse took place from Antarctic region, created by some of my friends. And I will not be, since time is running out, I will be closing here. And I will not describe any more further details about eclipses. These are some of the references. People can go to these sites and see more details. So just to thank the various people, the encouragement and support from Sri Pramod Kale, whom you heard in the morning. He was then director SAC when I conceptualized this experiment. And I am certain that no other person would have supported this kind of ideas, which are out of the box ideas, but he certainly did. And then he guided me in terms of how to contact different agencies and how to get the pre-insert commanded and data collected and all. Thanks to some of my colleagues who helped me in entire very hectic near real-time exercise that we conducted and ran through successfully. And of course, thanks to the organizers for giving this opportunity to me to share my experiences and excitement to you. And of course, I must thank the web resources where I took some of the images from. Thank you so much. And I stop here. Hello. Hello.
Thank you so much, sir, for such a wonderful talk. And
I hope you.
sure-
I hope you could listen to me because I could not get my visuals on my web camera, so I went on talking. I hope it was okay.
No, it
Yes,
was
sir.
okay, sir. Voice was also very clear and slides were also very clear.
Okay. Thank you.
Your
Now,
face
sir.
is right.
Thank you so much, sir, for such a wonderful talk. And I'm sure after listening to such an inspiring talk, whoever is listening to your talk, they will be eager to see next upcoming eclipse. With that, the session is open for question and answer. Maybe I'll take few questions which Hari and Amritanshuji they have put in the chat window. Uh, Let me just take a question. So this is a very good question from Archisha Sarkar asking about, can solar eclipse occur at a different part of the earth at the same time? And then there was another question, why solar eclipse or lunar eclipse do not occur on every new moon day or full moon day?
Okay. The first part of the question is, can solar eclipse take place at different places at the same time? Unfortunate on the surface of the earth. Unfortunately, no, because we have only one moon. If we had many moons of this type, then probably it can take place simultaneously at different places.
Okay.
Now, as I explained, the occurrence of solar eclipses or the lunar eclipses that depend upon the location of the sun and moon in their orbits. And when they come at the nodes, they don't always come. One may be ahead of the other slightly, or one may be above other or something. So the total eclipses take place only rarely, not all the time. Sometimes it may be just a partial eclipse, and it will be not a total solar eclipse. And sometimes, of course, depending on the distances also, eclipse may be annular or eclipse may be total. So this is a rare combination, and everything has to fit in the sense that sometime in the cricket you see the bowler is bowling, sometimes it will be a wide ball. It will not go and hit the wicket. So it's like that, but it has to be perfectly aligned, then only the rare eclipses can take place. Yes, please.
There is another question by Dr. Bharat Adur, who is heading Akash Ganga Center for Astronomy, and he happens to be also one
Yes,
of the knowledge partner for this event.
yes, we
So
heard
he
him.
wants to ask about diamond ring and Bailey's bits. If you are here, sir, you can unmute yourself and ask your question. Is he there?
Yes, please.
Bharat sir, if you are able to hear us, you can kindly unmute yourself.
It seems that you have not connected his
Hello.
audio.
Bharat
Can
sir
you
is
hear
here.
me now?
Yes, we can hear you, sir. Go ahead.
Nay, my question is as follows. Normally, in such eclipses, for a common man or people who are citizen scientists like Professor or Sir C.V. Raman, my question is, there is very much highlight on diamond's ring, but not on Bailey's bead. I would like to know from you, sir, that have we made any effort to look at the Bailey's beads during an eclipse? Because your missions have been by using satellites. And in that kind of a situation, is there any progress or movement to look at these events also? One of the events which I had observed in 1980, that you could see shadow bands
Yes,
during an eclipse.
yes.
And later on, I have been following eclipses for past 18 eclipses I've seen. And hence I am asking you that during your observation with satellites, were there any such kind of effects seen by your satellites? I hope,
Yeah,
am I
yeah, yeah.
clear?
Yes, please.
So
Yeah, let
these are
me.
my queries to you, that diamond ring, then the shadow band,
Yeah, I got
Baily's
the.
bead.
I,
So have you been able to see them also?
yeah, let me answer. Okay. Now this Valley beads and diamond ring are produced in the sky in the sense that certain part of the sun, the disk of the sun remains uncovered by moon. So you tend to see the sun shining through very small regions at the edge of the moon. So that is how these village beads are created. Now, secondly, in my experience of using the spaceborne or the satellite for eclipse studies, I have only seen the or the image the Earth during the eclipse. So no looking at the sun or the various beads. Okay. So my observations were related to what effects one can see on the surface of the Earth or in the atmosphere of the Earth. Now the third thing you talked about is shadow bands. Yes, during the Antarctic solar eclipse that we had made observations, we recorded most beautiful and most unprecedented long-term shadow band activity that lasted 7 minutes and 4 minutes on each side of the sun because the sun was shining through a large region of the atmosphere, sun being almost close to the horizon, and in the Antarctic atmosphere, the stability and the turbulence were there. So this eclipse, I have the full recording of 7-8 minutes of shadow band with high contrast. I was myself there, and we could see so beautiful movement of shadow bands created by that eclipse. And then we all recorded it digitally. So that record we analyzed and we published results also. And Dr. Voss is here. He was also co-investigator in that. And been we had taken a full expedition to the Antarctic station Maitri, and we were there for 15 days and made all the preparation, and it went on flawlessly as far as shadow band experiment was concerned. Now your question is more about shadow band, why they are occurring in different eclipses and sometimes not occurring and all that. That depends upon so many factors because how the sun is covered in the sense that does it become a very small angular size illumination region from the sun or depends upon the atmospheric stability and turbulence and all. Then again solar elevation and the temperature and all that play. I hope I have answered your question. But as far as looking at the village beads and what you call it, the diamond ring and all this from space, there have been many satellites which have been observing this kind of thing. And now coronagraphs are there in the on satellite, and India will also be launching its own coronagraph. So there will be possibilities to study this kind of phenomena from space.
Mhm.
Thank you.
Okay, thank you, sir.
Then we have a question from our team member Hari. So the question is, sir, we have developed equations and used simulations and models to calculate the next solar eclipse and the umbral path. In contrast to this, how would one have predicted such events in ancient times just by observation? And of course, it would have been only around the local area. So, any information about that?
Now, for this eclipse prediction has been there even before this mathematical and computer models. Because people have been observing the regularities in the moon's orbit for a long period of time. And then based on this kind of observation, they try to calculate and see whether this any such regularity is there. For example, the Saros cycles and all that. So they were able to predict reasonably accurately, not the accuracy which we have today, but they were able to roughly calculate when this next moon will be at the node and then when there is a likelihood of solar eclipse occurring or lunar eclipse occurring. But if present day calculations are very, very accurate in the in the terms of even a fraction of a second, you know where, and within a kilometer or half a kilometer, you know where the shadow will be, where its edge will be, and all that. So if you have developed this kind of mathematical model, we should popularize. For example, we all globally use Espanax calculations and then try to plan our experiment. And he has been a wonderful eclipse astronomer who has been providing this kind of predictions much in advance, very detailed predictions, and the whole astronomical community is using that for their plans. Fred Espenak from JPL.
Thank you, sir.
So
Next question.
Hello. Excuse me. Now you should also publish your tables in advance. Of course, over Indian region there is hardly any total solar eclipse for next 2 decades. Certainly, yes.
Thank you, sir. So next question is by Mr. Amritanshuji. Can you unmute yourself and ask your question?
Okay, good afternoon, sir. Sir, this is a small query which is out of only curiosity. Actually, sir, we had been talking about total solar eclipses. The annular solar eclipses have also come into play while you were giving this talk. I just wanted to know, sir, there is a third variety, which is a mix, that is the hybrid eclipse, which actually is very rare. Now, the queries like this, that is, it looks like a total solar eclipse from one place and annular solar eclipse from the other place. From your experiences, this may be a hypothetical question, but how will it be at the point where umbra meets antumbra?
Yeah, all this is part of the prediction in terms of moon's distance. During the time of the eclipse, the moon distance is also changing. So, an eclipse which may start as a partial and trying to become total, in the process, it might end up becoming annular only. So this is all, I think, nothing more than geometry that is known in terms of distances of the sun and moon and the earth.
Thank you, sir.
I guess there is nothing more to it than that.
No, I think then shall we move on to the next session, or do we have time, sir, for more questions?
I suppose the next session is likely to be in the waiting because we have overshot the time because the queries were so genuine.
I'm sorry for that. In the end, I had to rush because I looked at the clock and then I found that it's already 3 o'clock. Okay,
those who are interested in asking questions, they can write to us. We'll get an answer from Dr. Bhandari and forward to the participant.
Thanks everybody for their patience. Thank you so much.
Thank you, Dr. Bhandari.
With that, I thank the session speaker, Dr. Satyendra Bhandari, for such a beautiful talk on eclipses. And with that, we move on to the next session. So I hand over to Mathur sir.
Okay, Mathur sir.
Ashish, okay.
Yes, sir. Yes, sir, I'm available. Yes, sir. So thank you, Chintamani, and thank you, Bhandari sir, for a nice talk on solar eclipse. वैज्ञानिकों के बाद अगर चांद और सितारों का सबसे बड़ा इस्तेमाल अगर किया है तो बॉलीवुड ने, और इसलिए मुझे एक गाना याद आ रहा है कि आओ हुजूर तुमको सितारों में ले चलूं। खैर मैं गाना पूरा नहीं करूंगा वरना आप लोग वंस मोर कहेंगे। तो अब बारी है सितारों की ओर जाने की, क्योंकि अगला जो टॉपिक है वो है अमेजिंग वर्ल्ड ऑफ वेरिएबल स्टार्स। एंड आई रिक्वेस्ट डॉक्टर वैभव राउत, who is expert associated with SpaceX, to moderate this session and introduce our next speaker, Dr. N.M. Ashok. Please, Vaibhav.
Thank you, Ashish sir. Thank you all the panelists here, and especially Mathu sir and Jain sir for this opportunity. It is indeed a great pleasure to introduce Dr. N.M. Ashok, a senior professor and eminent researcher in the field of astronomy and astrophysics. Dr. N.M. Ashok have completed his BSc and MSc from University of Bombay, currently known as the University of Mumbai, in year 1974 and 1976 respectively. He pursued his PhD from Physical Research Laboratory and received his PhD degree from Gujarat University in 1982. Dr. N.M. Ashok joined Physical Research Laboratory for research career, where he was a chair of Astronomy and Astrophysics Division and senior professor. He has received Astronautical Society of India Award for Space Sciences for the year 2011. His research interest, yes. His research interests relate to classical novae and related objects, stellar evolution, infrared techniques, and astronomical instrumentation. He has more than 115 publications in peer-reviewed high-impact international and national journals. He has given guidance to several students for their PhD degree and also a large number of postdoctoral fellows on research topics related to novae, B stars, and astronomical instrumentation. Dr. N.M. Ashok have co-authored two popular science books on the Sun and planetary motions published by Vigyan Prasad, Department of Science and Technology. He has made important contributions in the field of classical novae and related objects that have received wide recognition in the international community and are highly acclaimed across the world. One of the substantive accomplishments he made in the identifications of the eruptive variable V445 Popes in the field of observed helium nova, in the first observed helium nova. Additionally, his study of two eruptive variables V838 Monocrotis and V4332 Sagittarius has clearly identified that the new class of nova-like variable exists, which mimic very cool supergiant stars with circumstellar disk harboring planetary bodies. He has participated in several national and international total solar eclipse expeditions to study the solar corona. Dr. Ashok is a member of Indian Physics Association, Astronomical Society of India, International Astronomical Union, which are the professional societies. He is on the editorial board of Bulletin of Astronomical Society of India. He is part of the astronomy research, astronomy outreach activities, where he has been regularly interacting with the college students to popularize astronomy and giving lectures covering various astronomical topics. In today's talk, he will talk on amazing world of variable stars. The amazing worlds of variable stars will be described, highlighting their contributions to the astrophysics. And I am sure that the talk by Dr. N.M. Ashok, an eminent researcher, will inspire you to pursue the field of astronomy and astrophysics and help you uncover the world of variable stars. With this, I welcome Dr. N.M. Ashok to deliver these talks. Thank you, sir, for joining. And now it's over to you.
Yeah. Okay. There. Yeah. ಇತ್ತಗೆ ಏನ್ ಮಮ್ಮ ಏನು ಇದು ತೆಗಿ. Hello.
Yes, sir.
Am I audible and is my screen ತೋರಿಸ್ತಾ ಇದೆ?
Yes, sir.
Yes. Okay. Fine.
The screen is very clear. Your voice is also
Okay.
very clear, sir.
Okay. Thank you for your patience. Yeah. So I could sense the excitement and eagerness from the audience. So it is quite okay that I'm a bit late. But जैसे सोनी जी ने कहा, जब तक चांद और सितारे रहेंगे हमारा प्यार अमर रहेगा. So this is what came to my mind. I thought I will start on this note and take off from where Dr. Bhandari told about solar eclipses. So I would like you to sort of relax for first few minutes. I will give a little introductory thing that I will take you much beyond the solar system and almost going to edge of the universe. And I would like to tell you that, so there are stellar eclipses also that are taking place. As it showed, though on non-eclipse days, our sun has been a very, very reliable star, which is shining without any problem. But when the eclipse takes place, so at a given place for a few minutes, so we see that its intensity has decreased considerably. And since moon shines by reflected light, so it becomes totally dark. So I will tell you about some stellar eclipses. So here, as I guess, large number of, say, school and college students are there. And I would like to just sort of invite them, as the logo of today's thing is. So those who are students, you may not take up science as a career, but that doesn't mean that you should not develop a scientific habit of thinking wherever you go in your career. So that has been the main effort for organizing today's lecture. So asking right questions. So, and this is one field in astronomy, the variable stars, where so-called amateur astronomers, because why I said so-called, because with this technology that is developing very rapidly, so today's amateur astronomers are even better equipped than professional astronomers of few decades back. So again, like say the sky doesn't belong to any country, or so it is there for all of us. So it has been a very wonderful thing, sun right from the beginning of civilization. So when man started looking up at the sky, so he has seen. So let me begin. So what I plan to tell you in next 45 minutes or so, I will give you a brief introduction to the variable stars. So you may be wondering what I mean, so it will become clear. So then the contribution or implications and the significance of studying this. So I have selected some exciting things the way I see them. I hope I will be able to convince you that what the selected contributions of the variable stars in understanding the cosmos interest you also. So I will tell you first about, say, measuring the universe, I have called. So distance measurement in astronomy is a very difficult thing. Okay, so here the variable stars have played a very, very significant and important role. And then we come to the next topic, stellar masses. So here, this again, say though we know that any mass has a gravitational field, and as I will tell you, there are stars which are much more massive than the sun, and also there are stars which are much less massive. But isolated star, a constantly shining star, it will be difficult to measure its mass. So this is where, again, these variable stars have come to our rescue. So because of a selected group of variable stars, we are in a position to measure the stellar masses. Then I will tell you why this is such a significant contribution, because it is the mass which decides everything about a given star. So this is the basic parameter which decides. And then I will tell you about, say, some spectacular variable stars, novae and supernovae. Then using the same set of, say, selected variable stars, I will tell you about light echoes in astronomy. We are all familiar with sound echoes. I do not know how many of you do trekking and go to caves. So in a cave, if you shout, so you are familiar with sound echoes. So I will tell you that in the universe, so there are what we call as light echoes. Then I will tell you about, say, exotic end products of the stellar evolution. I told you that mass determines how it evolves. So I will tell you about three possible end products of a star depending on its mass, namely the white dwarfs, neutron stars, and black holes. So if they were not varying, or for what reasons I will tell you, it would be difficult. And particularly say black holes, as the name says. And it is only the gravitational field that we can feel. But if a black hole happens to be in a binary system, then we are able to see its environment. And again, for all these three objects, say determining their masses is very important. So here again, these variable stars come to our help. Then the last topic, what I thought I should make you aware is about X-ray and gamma ray bursts. Say from post Second World War in last century till then, say before Second World War, it was only the optical window that we had access to look at the universe. Then say war efforts required radio. So we knew about radio sky. Then say as Bhandari has told us, so now we are no more restricted to the earth. So we go to the sky, and it is fortunate that these high energy radiations do not penetrate and come down to the surface of the earth. Otherwise, life would not have emerged. So I will tell you about X-ray and gamma ray bursts. Okay, so very sudden release of large amount of energy, bursts, the dictionary meaning. So let us continue. So let me tell you about some terminology before proceeding further. Like, what does one mean by variable stars? So what it means that there are a group of stars which change their brightness as a function of time. It is implicit in this sentence. As a function of time, the brightness changes. Then say on Earth or in lab, we are all familiar with the unit of say watts for quantifying the brightness. How do we do that for the stars? So historically, what say people have used a dimensionless quantity called as magnitude. So just briefly, I will tell you. So this was say based on what human eye saw, this was defined. Like as the sunset takes place and slowly sun goes below, twilight is over, and slowly we start seeing stars. So the brightest stars will be seen first. And as the sky gets totally dark, we see the fainter stars. So the range of stars that were seen by the human eye, they were classified into magnitudes 1 to 6. Magnitude 1 being brightest and magnitude 6 being faintest. So here it is an inverse scale. So for those who are still in the school and colleges, this will, if I say that, remember the ranks that you get from when you appear for your final exam. First rank, second rank, third rank. So the person with first rank gets the maximum number of marks. So same, so smaller magnitude stars are brighter. Then now this is precisely defined. Then this is a log scale because that is how our human eye responds to the sensation of light on the retina. So here, say this 1 to 6, that means difference of 5 in magnitudes corresponds to a factor of 100 in brightness. So a star of magnitude 1 is 100 times brighter than star of magnitude 6. So we will be using this unit. So then I will tell you how do we sort of keep record of this change in brightness. Because as Bhandari said, and earlier speakers also, so in science, we have to make observations and make records of that so that these can be shared and discussed to arrive at some conclusions. So how do we record this changing brightness? So this is done by what one says as light curves. light curves. So a light curve is a plot of intensity in units of magnitude versus time. And time, because now we want a continuous record. So the calendar dates are not simple enough because the same numbers keep coming, year changes. But however, we want a continuously increasing count of days. So not to miss the historical records, a Julian day has been defined that it is a number continuously increasing starting from the noon of January 1, 4713 BC. So all the earlier records we are able to study. For example, let me tell you, say today, unlike our normal day, it starts at noon because we want to see the stars and record. Okay, so unlike our solar day starting at midnight, so it starts at noon. So today at 12 hours noon, 28 February 2021, the Julian day, it's a large number because it starts from 4713 BC. Okay, 2,459,274. So just remember, and don't worry about this. So Julian day and magnitudes. Okay. So let me tell you and show you some typical light curves of variable stars. Okay. So they come in all variety. So just I have shown you. So here in all this, y-axis is magnitude. And here the numbers decrease as we come towards the origin, because as I said, smaller numbers are higher brightness. So normal plots, any quantity increases. So brightness increases upwards. So the magnitude decreases. And here, this is the Julian day, continuous. Okay. Here, this large number is subtracted. That is why you see smaller numbers. So this is another light curve. I will be coming back to this. There are different groups of these variable stars. Here you see there are three sets, different. So they decrease and in a different fashion. I will tell them what they are as we go along. So let us continue. Yeah. Then before coming to the topics that I told you at the beginning, I would like to tell you one more thing before we go and understand the contribution of variable stars to astronomy and cosmology. So here they are broadly two groups. One we call as intrinsic variables. Okay, so here the variability is caused by physical changes such as pulsation. I will tell you, the star sort of in popular textbooks it is written as it breathes, sort of when we take deep breath, okay, the lung and it expands. Then when we exhale, so air comes out of the lungs, so it shrinks. So pulsation. Then the other one is eruption, like things are thrown away from the star. I will tell you why these things take place. And the other thing is the extrinsic. So just now we heard about these eclipses, okay? So sun continues to remain as bright as it was. Only for the Earth-based observer, an additional object comes in front of the sun, so we see these eclipses. So this extrinsic variable stars, here the variability is caused by the eclipse of one star by another, or by the effect of stellar rotation. So eclipsing binaries and rotating variables, they are called. Many of you would have heard about sunspots. The percentage of sunspot is less than 1%. So there are some stars very active. Their atmospheres is very active. Almost, say sometimes 30–40% of the star's surface is covered by the star spots. So as the star rotates, the percentage of spots which are relatively dark, faint, increases or decreases, so it changes. Okay, let us continue with this. The first interesting thing. So measuring the universe with Cepheid variables. So in astronomy, so any group of stars which have a similar property, we give the name of a star that was first discovered to have that property. So Cepheid. So in honor of the first thing, so the way other variables having similar properties are called by that name, Cepheid variables. Cepheid is the name of the star. So here, these are pulsating variables, stars with periods of days to few months. Okay. Then how we can measure becomes clear. And then these are very bright. Okay, very bright. Hence, we can see them at large distances. By large, what one means? Say, for solar system, say going to Neptune, Pluto, Uranus, these are far off objects. So for a Milky Way, going to far off from the sun, say that is far off. But in cosmology, we have to go much beyond to external galaxies. So these are called as cosmological distances. So to measure this, so these Cepheid variables, since they are bright, because as the distance increases, their brightness decreases as inverse square law. So if they are very bright, we can see them at far distances. Then these Cepheids not only are bright, but they show excellent correlation between brightness and period. So this is called as period luminosity relation. Okay. So for some Cepheids, independently, if we know determine their distances, and then from the light curves, we know the period. Then, so period and brightness. Luminosity is another technical term for brightness. It is related, PL. So once you know the period, you know the intrinsic luminosity. So you know the observed brightness, simple inverse square law you use. So you know the distance. Okay, so this is the significance of Cepheids for measuring the universe. Okay, so same thing, what I described is shown in these two graphs. So this is typical light curve. So a faint, say large number, okay? So, and this is here, it is time only. And since it is periodic, so one period, like for the Earth's orbital period, 1 year, one we call. So then this we subdivide and say from 0 to 1. And then again, it increases. So here 1 is equivalent to 1.3087951. You see, going up to 6th or 7th decimal place. That is how we are able to precisely determine this period. And then I told you about this period luminosity. So here you see luminosity in terms of sun. So there are Cepheid variables 1,000 times brighter than the sun. 3,000, 10,000, 30,000. Then with increasing luminosity, their period increases. You see, x-axis is period in days. So let us continue. Here, important, because many of you would have heard about Hubble's law. During Second World War or prior to that, a pioneering work was done by Hubble, where he determined distances to the external galaxies. Then, this is the famous Hubble's law, the recession velocity it is called. You are all familiar with Doppler effect. So using that, we can determine the velocity. So in the universe, nothing is stationary. Things are always moving. So these external galaxies, they have their own, say, recessional velocities, because the adjective recession is used, because it was noticed that with respect to Earth, everything is moving away. This you see again. V increases as a function of distance. And this is the Hubble's constant, capital H. This gave rise to, expanding universe. So measuring Hubble's constant is a very, very important thing. Like different groups who are favoring one theory or the other about the universe, they fight tooth and nail about that their theory is right. So this is observationally, finally in science, what is true in astronomy. Finally, observationally, what is seen is taken as the proof. So here you see, sorry, the lower picture. So distance and velocity. So it is kilometers per second. Okay. And these are different galaxies. Symbolically, they are shown. So now, okay, with this, I will go to the next one. Stellar masses. This is again another very, very difficult thing. So this again, say Kepler's third law of planetary motion. Okay, we know, which is written here. Say period square is proportional to distance cube. If we use the unit of year as period and astronomical unit, average distance between Earth and Sun as the astronomical unit 1. So this becomes simple p square equal to a cube. And here again, say putting the gravitational force, and the same thing works out to ma plus mb equal to a cube upon p square. So here it was for Sun, it was taken as 1 because everything, okay. So this applies to here, it was Kepler's laws first derived for planetary motions, that means planets and the Sun. So then people noticed that like universal gravitation that Newton told. So this also applies to binary stars. So same thing. So here MA, MB are the two binary components. And to get this say period and so distance. So here is these two groups of variable stars, eclipsing and spectroscopic. I will tell you what they are. So I will go a bit fast. Just don't worry about the details, just the concepts. Eclipsing variable. So binary system with respect to the heavier mass star. So we can consider that really they move around center of mass. So practically it is say center, like here also. Sun also moves around the center of mass, but it is within the Sun's radius itself. And if this orbital plane, as Bandari was telling, why somebody asked, why eclipses do not take place on every new moon and full moon day. The orbital plane has to lie in our line of sight. So those binaries for which orbital plane is close to our line of sight, when one of the star comes in front of the other, so intensity decreases. A brighter star, when it is eclipsed by a fainter star, so there is a large drop in intensity. Then there is one more drop about fainter star going behind the brighter star. Okay, so these are called as eclipsing variables. And then there is again, say spectroscopy. So if we look at the spectra, so the Doppler thing, what I told. So same, say take example, just A and B it is taken. So 4 epochs in time, 1, 2, and 3 in the lower figure. So when star A is approaching us, so it will have a blue shift. At the same time, star B is going away from us. So the spectral line, say from hydrogen, is split into 2. And when they are moving at perpendicular direction to us, because it is a line of sight, so there is no relative movement. So both lines merge and become one. Then again, at 180 degrees away in the orbit, again it changes, it splits. So these are called a spectroscopic variable. So to determine this A, P is easy, okay, eclipsing variable. And here, so if we know the velocity and a duration of these eclipses, we get to know the size of the stars. So we are able to, okay, determine what I showed you here. So this MA and MB and eclipsing variables are needed because we want to know the I. Otherwise, there is a sin I thing. Let us not worry about that. So if we have a binary star, which is both eclipsing variable and spectroscopic variable, we can determine the mass of individual stars. So now let me go on to the next. So I've called them as spectacular variable stars. Okay, that means all of a sudden, apparently for no reason, as a common man may put, they suddenly become bright. So nova in Latin means new. So a nova is a temporary new bright star. So it brightens, but again, then depending on different properties, it fades over next few weeks. Okay. So here, spectacular, I told. So this increase in brightness, say in nova, they are 100,000, say, times brighter than the sun. So within a day, it brightens by such a large amount. Then say again, say super adjective. So this was, sorry, 1 lakh. But here, supernova, the increase can be as high as billion times. Okay, so supernova. So these are the two. I will just show you. Say in 1975, one such nova became bright enough to be seen by the naked eye. So Nova Cygni it is called, named after the constellation and the year in which it was discovered. You see all the other background stars have remained at the same brightness. So this faint one has become so bright. Okay, so this is the light curve of the nova. So suddenly it has become bright, the magnitude numerically has become less, and then over next, say, 1,000 days, it comes back to its own earlier faint magnitude. Okay, let me tell you why this brightness happens. So this is an artist's impression of a nova system. So here it's a binary, and here one of the components is a special star, what I was telling you earlier, white dwarf. So we know what will tell us later after tea break, sun. So the sun shines because of thermonuclear reactions taking place at its center. So here, this explosion happens because on the surface of this white dwarf, there is a uncontrolled, so it is called as a runaway thermonuclear explosion on the surface of a binary system hosting white dwarf. Okay, so this. Now, few minutes, the importance, astrophysical significance, I will tell you. I have selected just one part. So novae are unique laboratories to study dust formation, grain growth, and destruction. So universe, the different components, say gaseous component and dust, then radiation. Okay, there is light, there is gas, and there is dust. How this dust is formed? So novae, some of them form dust. So we see fresh, like garden fresh apples or garden fresh, say grapes last 10 days. So these are unique laboratories where fresh dust is formed, how it grows and how it gets destroyed. So same is shown here. What? Like there are 4 states of matter: solid, liquid, gas. So in physical situations, say plasma and gaseous state are most common. The liquid phase is relatively less seen. So, and now we know that there is water detected in the close to the star spots, atmospheres of many stars. And then there is a solid state phase. So this is the dust. So novae help us study the dust in different astrophysical context. Okay. So this I'm showing you because astronomy lecture should have some good slides. So you see here on the left. So sorry. So either dust can be detected by what it is blocking, absence of light coming. So on the left side, you see central part as donut kind of thing. No stars are seen at all. Okay. So this is because dust, it obscures. It is not that stars are not there. So particularly for us who are in Ahmedabad or who are listening, who are in Rajasthan, or so like this dust storms. So we see the sun becoming very faint. So here, this is the dust which is obscuring the light from the background stars. So we see this. And on the right-hand side, you see another very impressive way the dust manifests itself. So it is known as Horsehead Nebula in the constellation Orion. So this is again blocking the light coming from the background stars. Okay. Then you see diffuse thing. So there is this reflection also coming from the dust particles. Okay. Okay. Let us continue. Then I will come to the supernova later. I will go a bit quick. I told you about light echo. Let me just spend 1 minute about sound echoes. So here, I will tell you about, say, one place in Karnataka, northern Karnataka. So there is the very impressive structure that you are seeing, the monument, which is called as Gol Gumbas. This is there in Vijaypura in Karnataka. Earlier name was Bijapur. So this is also known as Whispering Gallery. In fact, Professor Raman has written about this, how these echoes are generated in the dome of Gol Gumbas, as Professor Kale was telling. So collected works. So there is a very nice article by Raman on why these echoes are so prominent here. So this is a Q-shaped building, 47 meter side with a 44 diameter at the top. Okay, quickly I will go you. So here you see light echo. What do we mean by that? So if we have a sudden impulse of light and around the source, there is material. So first, for an observer who is seeing this here, so he sees the direct light coming from this transient source. I have been telling you about this spectacular novae, and I will tell you about supernova. So direct, and then the light will be going in all directions with respect to that star. So surrounding material will be reflecting that, scattering that. So that comes to us. So that is the light echo. So most iconic light echo that was discovered in beginning of this century, say 2002. So here you see this 4 Hubble Space Telescope images of this. It is a variable star. Don't worry about that. Constellation and the number. It means 838th variable star to be discovered in constellation Monocerotis. So on 4 occasions, May, September, October, and December 2002, you see this light echo expanding. Okay. So this is what I thought I will share with you. Yeah. So now, say from these spectacular variable stars, another context where this is very important. Physically, what do we use these light echoes for? So in last few years, detecting this extra solar planet is becoming a very important and hot topic. And planet formation, clues to that. So here, if we understand what one calls as protoplanetary disks. So the central star is still forming. Around that is what is called as protoplanetary disk. Slowly it will condense and different planets will form. If we can study and get these details, we will know about the planet formation. So here, these stars are so far away. So imaging and separating out is very difficult. So again, say light echoes will tell us how far this, say, protoplanetary disk is. Let me show you that. So here you see, center is the light. And these stars, say, before they settle down, they change in light. So first we see a change in light from the central star. So the green thing, then after a time delay, we see this light echo from the disk. So these time delay measurements will help us to find out about this inner gap, because it says that what is the closest distance where planets can form. So this is another context where light echoes are used to study young stellar objects and protoplanetary disks. Okay, let us come to this next spectacular thing. Stellar outburst, supernova. I told you, super. Okay, so billion times. Then I told you about nova, that this outburst took place in a binary system where white dwarf was there. Then I told you about stellar masses, that masses of stars come over a large range. So these are divided, like those of you who in our society, we use the term low income group, middle income group, high income group. Okay, so same. So low mass star, high mass star, intermediate mass star, they are grouped. Because depending on the mass, they evolve in a different way and end up in a different way. So a massive star, so when it reaches its end point, okay, suddenly, so sort of implosion. So it collapses and a neutron star or a black hole is formed at the center. And at the same time, so much of energy is released that outer layers are thrown away. So the last supernova that was seen on our Milky Way galaxy was way back in 1604 by Kepler himself. Since then, they are not seen. So, however, we know that statistically there should be 3 supernovae that occur every century. So a visible supernova in our Milky Way galaxy is overdue. So as I said, billion times. So there is a record way back, okay, in Taurus, where this star supernova thing, this was seen even in daytime for several weeks. Okay. So, however, I will tell you about a supernova that was seen by naked eye. It became bright enough. See this number on the right side, light curve, little more than 2. I told you that we can see up to 6 magnitude star. So this was in the southern sky. So it was not seen from most of the India. Okay. However, say south, Madras, Kanyakumari, because it is in the southern sky. So it is a satellite galaxy of our Milky Way and named after the person who crossed the equator and looked at the southern sky, because say all the civilization or all the continents are in northern hemisphere. So Magellan. So there were 2. There is another one, small Magellanic Cloud, large Magellanic Cloud. So I will take another 5 minutes or so and quickly go through. So let me not cut into the tea time too much. So supernova, okay. And why should we study and what do we learn? Okay. So here there is an intimate connection between say supernova and we human beings. That means say solar system. So as Professor Kale was telling, so initially in the universe, it was only 90% hydrogen, remaining helium. So where did this all heavy elements come from? So this is technically called as stellar nucleosynthesis. Don't worry about this word. So these heavy elements like calcium, iron, these 2 I listed because calcium in our bones and iron in our red blood cells, hemoglobin. So these came from interior of a high massive star, which exploded as a supernova. And all these were synthesized and they were distributed. So second generation star like our sun formed containing this material. Okay, so that is how humans or life evolved on Earth. Okay, then we need this other thing. Okay, gold, silver for ladies, and for people in space industry, titanium, very strong lightweight metal. Then for energy, uranium. So all these have come from supernova. We are intimately connected with, say, stars. So then again, this 3-dimensional structure of the universe. So same I have written, formation of solar system might have been triggered by a supernova. So I will take just 5 minutes and quickly go through. So X-ray sky, I told you, say, after the space era, so we now know how the sky looks at all over what we call as the electromagnetic spectrum. The normal processes, the radiation and what we call all this that we see, black body is the technical word. So the temperatures I said. So the general thing that most of the radiation is in the optical and infrared. Nobody expected things to be seen, say astronomical or cosmic objects at X-ray wavelengths or even gamma ray wavelengths. So it was a big surprise. Okay, so they are, again, I told you about 1,000 times more energetic than visible light, X-ray photon. They are produced by violent explosions and high temperature environment. So you remember when you either you have fractured your hand or leg, you go to take your X-ray to see the fracture and dislocation. The person who operates the machine wears a protective cover, okay? And a small, briefly, it is shown on our part which has suffered damage. So that means there are locations in the universe where there are violent explosions taking place, high temperature. So this is where the X-rays come from. And again, say these sources vary on very different time scales, okay? From milliseconds to minutes to hours and days. Then they show dramatic variability, I will tell you. Now that the cricket match is going on, say in last 20 years, say we have this test matches, 5 days, then we had 1 day, few hours each team, then we have T20. So here also, so there are variabilities, stellar variability, millisecond, minute, hour, days, and years also. Okay. This again an artist's impression. So I told you, yeah, sorry, about this nova. So here, this is instead of a white dwarf, it has a neutron star or a black hole, which is having even more high or very gravitational field. So it is the gravitational energy, okay? So the material from the companion is dragged. And as it goes and falls on this, so its velocity is increasing. So there will be collision. So extreme temperatures are developed. And when it falls, there is this runaway thermonuclear reactions also. So this is where this X-ray bursts come from. Quickly, I will complete in a few minutes. I will show you here an unusual X-ray burst source. Like we are all used like this for training and all, when these rifles or guns are used, okay? So even fastest that one can do, he has to reload and before he fires again. Okay, now we know these machine guns and AK-47 and all, where continuous stream of bullets are thrown out. So here is an example, a light curve in X-ray of a special source, rapid burst. You see, in 3 hours, it has say, so many outbursts. So same, it is expanded. Middle panel, 30 minutes. Okay, lower one, 5 minutes. That means every minute there is a burst. Okay, so now let me quickly come to this last one, gamma ray burst. So there even again say short-lived bursts of gamma rays, most energetic form of light. Let me quickly go through more descriptive. So here from anywhere from milliseconds. So this in roughly about one was detected in 1990s. So there is a interesting historical reason. Say this was the Cold War era. US and Russia each were suspecting that they are detonating nuclear, doing without announcing to the world. So there were US military satellites to look for Soviet nuclear testing, which violates this ban. Okay, so they carried gamma ray detectors. So they detected. But initially they thought it is coming from this Russian things. Subsequently, when they had sufficient data, so when they could determine the direction, they were not coming in that. So they were coming from all over the sky. So, but then we still didn't know whether they are coming from our galaxy, Milky Way galaxy, or outside. Okay. So now we know that they come from external galaxies. Okay. Yeah, this is again a schematic representation. And there are two, some which last long. By that, what one means is it's a relative term. So more than 2 seconds. So long gamma ray burst. There are other short gamma ray bursts, less than 2. So here it is again another single star, long one. So it collapses and then gives. Here it's a binary. So they merge. Okay, gravitationally come close and merge. So this gives rise to so-called short gamma ray bursts. So summary. Okay. So in last 40 minutes, I tried to tell you about the properties of variable stars, and they have been very, very important for our understanding the universe. Using the Cepheid variables, so we could measure the distances. So we have an idea about how the universe is made up of. Then we could measure the star masses. Then from spectacular variable stars like nova and supernova, we know about the properties different. Then light echoes. Then all these to study these exotic end products, white dwarfs, neutron stars, and black holes, and then X-ray and gamma ray bursts. So I will stop here. Thanks to all the audience for your patience. So I will, stop here instead of. So that is why I went a bit fast, where it was mainly qualitatively trying to convey you the excitement. So it will serve the purpose of the organizers. So you may not take up science or engineering as your career, but remember, so just have this scientific look. Okay, I stop here and thank you. Yes, Vaibhavji. If there are any queries, yeah.
Thank you, sir, for such a wonderful talk. You have covered the astronomical objects like Cepheid variables and other variable stars, which are also helping us basically a most challenging job, which is measuring the distances in the astronomy. And then we all know that we have the stellar luminosity and distance measurements, and then all stellar evolutions, which are described by the HR diagrams, and where this variable stars plays a very important and critical role in measuring the distances, and hence finding its apparent magnitude, luminosities. So there is also a large scope in doing an experimental studies. We have some questions from the audience. So I will.
Yes, please. Yeah, sure.
Yes. So there is one question is from Anand Chaudhary, Anand Singh Chauhan. What is the probability Sun will become a red giant and become and burst into supernova?
Nice question. So certainly, our sun is going to become a red giant. So that is we know for certain, but time scales are very large. We don't have to worry. So it will take another 5 billion years. So dramatically, it is said that when it becomes a giant, and the Earth will be absorbed in the sun. Okay, and as I was telling you, it depends on the mass. So it is a typical low mass star. So it will not become a nova or a supernova. So it will end up as a giant and lose the material and settle down as white dwarf. Okay, so that is why this group say leaving the Earth and going beyond what sun will expand is another practical use of space exploration. Yeah, nice. Yeah, okay.
Yes. So all stellar objects have certain lives. So yeah. So there is another question. This is from our panel, Bharat Mehta sir, I think. So do we have an astronomical instruments to measure the brightness of the star?
Oh yes, yeah. Good that you asked. So these days, these days, say nobody goes without a mobile. So another extremely useful use of mobile is to measure the brightness of stars. So thank you for asking this question. So now in these hi-fi mobiles, so there is a scope to have this delayed exposure and also manual. Earlier cameras had, so you can expose it for say more than few seconds. So please try it out. So I told you, say now even with a simple mobile, you are more powerful than Galileo and Kepler. Okay, so you can certainly use your mobile. Then of course,
there are some apps are developed also, right, sir? Which are
right, exactly. Correct. Softwares are there for digitizing this. Even JPG things, like what Bhandari was telling, so they have to be confirmed, changed into another format. FITS it is called. So there are softwares and very powerful apps. Mobiles are very useful for doing observational astronomy. And I will just emphasize. So this is variable star is one field. There are so many of them that simply professionals cannot afford to study all of them. So it has been a most useful interaction between amateurs and astronomers, professional astronomers, that has benefited both of them. So that is what I meant, that even if you don't end up in ISRO or other things, keep up your interest in astronomy, develop the scientific attitude and contribute. Yes, thank you.
So at school and college level, one can actually
Yes.
do an hands-on experiments.
Yes, correct. Yeah.
Right.
Like in the other earlier lecture, what Bharat Adur was telling. So citizen astronomy is the new buzzword.
Citizen
Okay.
scientists.
Citizen scientist, citizen astronomy. Okay. So then with so much of data which is there, so they want people to use and analyze. Otherwise, so much of buried data will go useless. Like ISRO also has started sharing the data from AstroSat. Yes, very much.
Sir, we have a few questions from our panelists. I will ask them to unmute. So the first questions, few questions is from the Ankush Bhaskar, who is currently Inspire faculty at Vikram Sarabhai Space Center, and also the co-founder of Space Geeks. So I ask Ankush Bhaskar to please unmute, and you can ask your questions. Then I will come to Amritanshu.
Hi, can you hear?
Yes, Ankush, please go ahead. Very clear.
Yes, sir. How are you? After a long time.
Yes, fine. Nice. Yeah, I forgot. Yeah, before answering your question, let me thank the organizers. So in the excitement, I got carried away and didn't thank Mathurji and Vaibhav and all the organizers for giving this great opportunity. Okay, yes, Ankush, please go ahead with your question.
Yeah, I have just two questions. One was like this Julian date. Any specific reason? The
Yes,
year it starts on?
yeah.
Why it is like fourth?
Yeah, it is a historical reason. So there have been reforms in calendar. Okay, Gregorian calendar, leap year. So it is a subject by itself, and so astronomers are very forward-looking, but at the same time want to continue the tradition. So they use the thing earliest starting point that was defined as 0 point. So that is the reason. Huh? Okay, that is the reason. So it is continuing, and there is a now, since those numbers are large, so modified Julian day (MJD). So this large number is subtracted. Yeah, that is a historical reason. So and again, so all the yeah. Yes. Next question.
Astronomical. Anyway,
Yeah.
okay. Second question I have like, how is the distribution of these heavy elements in any galaxy?
Yeah.
Because if it is, are there any patches in galaxy where you don't see any heavy element? Means stars are not there. Those. So that will affect us searching for life, right? Or a habitable
Yeah.
planet, because those regions don't have heavy elements, so we don't expect life formation also.
Yeah, very good question again. Yeah, that is true. I told you. So there are like, if one does unbiased and random search, it will take, say, large time and not end up fruitfully. So what he's telling is use other additional clues and where the probability is large. So in last few years, now it is one calls as search for habitable extrasolar planets. First, it was search for extrasolar planets. What you say, yeah, that is true. But at the same time, so determining this needs, say, spectroscopy. So what you say, if we have this, so there are things, okay? So distribution, spatial distribution, so of element-wise abundances. So people are using this to pinpoint and take a subset of stars and look for planets around them. Yeah, heavy elements is one. Yeah, very, very correct. Even in say meteorites and all, huh, people look, say origin of life on Earth itself. Try to look for this. Yes,
Okay,
heavy
thank
elements.
Okay. So Ankush, that's all from your side?
Yeah, that's it.
Okay.
Anything?
So I will take one question from audience and then I will go to Amritanshuji. So one is from Priyesh Jain. How do we able to measure the distance of the star? That is the suppose some distance light years away from us.
Yeah, I will tell you. Yeah, I told you about this like Cepheid and again other supernova. So otherwise, say the most direct thing is trigonometric parallax.
Yes.
Trigonometric parallax. We all remember in our school days. Say we cannot cross a stream or a river and we want to measure the distance. Parallax it is called, meaning apparent movement of nearby object with respect to the background object. So here distance and parallax, okay, they are inversely related. So people have been using, say, the largest baseline one calls, so the parallax angle. So if you measure the same thing from two locations and the angle subtended by this, if you measure and you know the baseline, simple, tan theta is small d by capital D. So to increase, say, because as distance increases, theta becomes less. So you need long baseline. So people used, say, orbital radius of Earth's orbit. Say, take a photograph today and take a photograph after 6 months. So Earth has moved on the other side of the sun. So 2 astronomical unit and then measure the parallax angle. Even this gives up to parsec one calls, 100 parsec, because scintillation, twinkle, twinkle, little star. So it puts a limit. So there was a special space mission known as Hipparchus that was flown by Europeans. So it increased this direct measurement up to 1 kiloparsec. Then you have the calibration and then use it for others, like nearby supernova, brightness, and then use this yardstick. So this is one of the difficult things. Then I will just mention one thing, contribution by one Indian astronomer, Vainu Bapu. He was studying the solar type stars. So in what will tell, so calcium absorption line. So it has a central emission component. The width of this is proportional to the distance he found, Bapu. So it is known as Wilson-Bapu effect. So these are the direct measurements. Then you calibrate and use them. Yeah.
Thank you,
Yes.
sir, for elaborately answering this. And these methods are explained in basic astronomy books, so they can also refer and study those further, various distances. Now I go to Amritanshu, sir. Can you, sir, please ask a question?
Thanks, Vaibhav sir. And first of all, let me thank the organizers, because I have been reading about Ashok sir, and for the first time, this is my personal interaction. So thanks, organizers, for bringing him from books live to me. So, sir, since we have talked about the father of modern Indian astronomy, Professor Bapu, so regarding his work only, I was just wanted to ask, that is with reference to your slides on stellar evolution. I just wanted to know, there are two complementary parts to it. That is, how will the rate of gravitational collapse of a star will vary after it sustains the main sequence of stars with reference to time? And as a supplementary to it, my inner query is, that is, will the convective envelope of the star also decrease as their stellar mass increases?
Yeah. Okay. Yeah, nice. This is related to the stellar evolution. So the time scale part I will answer first. So what he said, the most stable phase like what the sun is. So in universe, so it is always, there are four forces, but for the stars, it is a tug of war between gravity and outward force due to nuclear and thermonuclear reactions giving rise to outward force. So initially it is gravity which is taking over. So the time scales of the star formation are very less. Okay. So a fraction, like say the stable part, what you said. So the 90% of the time, stable part, star like sun. So stable, it is called as the main sequence, and one of you mentioned about HR. 90% of the time they spend on this main sequence. Like here itself, say we go very fast up to our college days. Then various things, our height, weight, they stabilize. Then say 50 to 60 years, this is the most stable phase in our human life. People have given this analogy between human evolution and star evolution. Then we start, say, growing either too fat. So then we want to do diet and we want to lose mass. So the time scale, so remaining 10% is shared between what one calls a star formation and star end phases. Okay. So 90% is the stable phase, and then remaining thing is the other. Then again, so this convective, what he said, energy transport, it is related to the energy transport. So the energy is generated in the interior. So again, depending on the mass, so one talks of, say, different things. We know about conduction, convection, and radiation. So the equilibrium, so convective equilibrium and radiative equilibrium. So in the stars like sun, it is the convection. Then high mass stars, it is radiative core. So depending on the mass, so this will decide. Then this convective layer also, will change. The red giant phase, the atmosphere will not be very convective, or it will be expanding. So it is a very interesting interplay, and the various parameters, physical parameters change. So this is where the variable stars give us an occasion. Like a good healthy person, if you study, it is difficult to find out. हाँ मरीज को देखने से क्या है पता चलेगा. So these are like that, which give us clues as to how good stars are, the way why they are stable. Thank you.
Thank you, sir.
Nice.
Thanks a lot for spurting this imagination by opening the Pandora's box of imaginative ideas after such a lively talk. Thanks, sir. Over to Anchor, sir.
Thank you, sir. One question is from our panelist, Satyendra Bhandari, sir. Sir, can you please unmute and ask your question? Bhandari, sir.
Hello.
Yes.
Yes. It is a simple one. I just wanted to know the solar 11 year cycle. How does it fit into the general set of intrinsic variable stars?
Yeah. Like here, na? So I
Our
told
own-
about star spots. So, yeah, correct. Similar to this, there are, say, cycles in other stars also. Okay. So this is related to the magnetic field. So 11-year cycle. So there are stellar cycles which are there on either side of 11 years. So there are few years and there are even longer than 11 years. So because this magnetic field in sun on the surface, it is very less. So there are stars with much higher magnetic fields. So we have this, I told 40% sun star spots. So stellar cycle. So this, like again, so it is called as, so like this earthquake, using them to measure the internal structure. So sun, say solar observatory studies sun by this, okay? Stellar seismology, helioseismology, stellar seismology. Yeah.
Seismology,
So,
yes.
right. Yes, Vandari.
Good. Thank you.
Okay. Thank you, sir. We have one more question from YouTube from Aruna Nagarhalli. So the question is, okay, so my question from Dr. Habu the Heavy. noble and precious metal found in the nova are in which state of matter?
Yeah. So I mentioned about this dust. So when it is dust, it is in the solid phase. It is in the solid phase. Otherwise, say in the gaseous phase, they will be like gaseous heavy elements. So the spectra show that. So and even we have this radioactive things like aluminium. So in some novae, but when it forms dust, so it is in solid state. That is why this interest of studying the freshly formed dust around Norway.
Yes.
Yeah. Yeah. So he was unable. So he passed on this question. Yeah. Thank you, Dr. Habu.
Yes. So, sir, I have one question from my side, just to have question in with the recent news of this intensity variation of the Betelgeuse and its possible explosion into the supernova. So, how
Yes.
excitement and what kind of things going in your
Yes.
mind?
Yes. Yes. Yeah. Yeah. It is what Vaibhavji is asking. It is say brightest red giant super in Orion constellation. So it is. Yeah. I will also mention that direct imaging by Hubble Space Telescope. So we have people have astronomers have resolved the surface. So we have an image of the atmosphere of the Betelgeuse. Yes. Yeah. So it could, but then, yeah, if it happens in our lifetime, it will be interesting. So some flares are likely to be there, but the whole thing, say expanding, and the other, I may take the liberty and tell you that other thing related to this, say, novae. So there is another way of forming supernova. So this white dwarf, if it reaches the surface, the limit of Chandrasekhar mass limit, it calls other thing. So then a known nova, I told that it is collecting material. So the white dwarf mass is increasing. So there are heavy white dwarfs in binary systems. So it is likely that one of these may become a supernova. Okay, if it crosses that, then it loses this, what one says that electron degeneracy, it cannot support. So this nova will become a supernova.
Right.
So in 2009, so there is one USCO, it is called. So otherwise typical novae, they recur after 1,000 years, whereas this shows outbursts every 10 years. So it is a very high mass white dwarf, which is likely to become a supernova. So, and I said already supernova is overdue. And you may ask, I will ask the question myself, when I say that 3 should have been there in every century, after 1604, why it is not seen? Again, it is the obscuration effect of the dust. So the dust, it is not that supernovae are not taking place.
Right.
So they are not seen because of the intervening dust. So it has, yeah, like anything has two sides of the coin. So good effect and bad effect. Yeah. Thank you, Vaibhav, for so
Thank you,
nicely
sir. Thank you,
coordinating.
sir,
And
for answering each questions so elaborately and delivering such a wonderful talk. And I hope that all the participants will take an inspiration and they will try to look at least from the handheld mobile phone. They can look at the variation in
yes.
intensity maybe in coming days,
Yes.
not in an extreme
Yes.
sophisticated laboratory experiments having
Correct.
telescopes and
Correct.
CCDs. So.
Correct. Correct. Yeah.
So I now hand over this to Ashish ji for further event
Yeah,
sessions.
thank you. Thank you very much, Dr. Vaibhav, and thank you very much, Dr. Ashok. You have thrown the light on amazing world of variable stars. Now I ask Mathur sir whether we should go for a tea break or we should continue with our next session. Mathur sir, kindly comment so that I can proceed accordingly. Because I think our next session is from 5 o'clock and we are having only 20 or 15 minutes to go.
Excuse me, I just wanted to interrupt in between. On YouTube stream right now, we are able to see only thanks part. So,
okay,
speaker
Dr.
sir,
Ashok, kind of please your
Yes, I will stop the sharing the
yeah,
screen. Yeah,
okay,
yeah, I
okay,
didn't
fine.
realize. Yeah, yes. Okay, Ashish ji.
Yeah, thank
Sorry.
you, sir.
Yeah.
So I'm waiting a call from Dr. Mathur to have a tea break, or we should continue with our next phase or last talk for today's
Yes.
event. Mathur sir is available?
He is logged on. Yeah, mute.
Yes, he is there, but I think
Our Jain Saab can clarify.
I think only you can take 15 minutes break instead of a long break.
okay,
Because,
correct.
15
So
minutes.
we have a very short break for just for now, and we have a last session on exploration of the sun. I request all of you to join by 17 hours, and I must say that few lines for this tea break, that राम युग में दूध मिला कृष्ण युग में घी, राम युग में दूध मिला कृष्ण युग में घी, कलयुग में मिली चाय तू फूंक फूंक के पी, तू फूंक फूंक के पी. And one more addition, in this कोरोना काल में काढ़ा मिला तू फूंक फूंक के पी, फूंक फूंक के पी. So let's have a short break and we'll meet at 17 hours. Thank you.
Okay.
Thank you, sir.
अशोक जी, आपने जो पिक्चर लगाया है लास्ट स्लाइड में, दैट इज आल्सो गुड. माउंट आबू टेलीस्कोप है.
Yes, correct, sir.
Oh, yeah. Thank you.
As a
Yeah.
mechanical engineer, I have contributed
Yes.
in that.
Yes. Yeah. Right now, one more
Yes,
bigger
yes.
telescope is coming.
Correct.
Yes.
Thank you,
Yeah.
sir.
Thank you. Yeah.
Sir, I'm just stopping live stream for 15
Yeah.
minutes.
Okay.
Yeah.
Okay.
Yeah. Yeah. Leave and join back. Yeah.